Okay, today we want to solve inequalities. This video deals with solving quadratic inequalities. So let's get started. I've got the definition. A quadratic inequality is an inequality that can be written in the form ax squared plus bx plus c less than 0. This is your standard quadratic form, remember. Okay, and then of course the coefficients a, b, and c have to be real numbers, and a can't be 0. So other inequality symbols can also be used. Remember that we can use less than or equal to, we can use greater than or equal to, and I suppose we could use not equal to. So our steps for solving: we want to solve the corresponding quadratic equation. We want to be able to identify the variables on a number line. Okay, so let's go back to step one. We're going to take the inequality that you see here, and we're going to convert it to an equation, solve it like using our methods that we know how to do. Then we'll plot those solutions on a number line, identify the variables, and solve the equation. So we'll use a test value for each interval to determine the solution set. So let's get started. Notice I have a quadratic inequality in standard form. It does factor, so that's the easiest way to get this thing solved. So I'll set each factor equal to 0. Easy enough. All right, now I'll go up here and plot my solutions on the number line. Now since I have the inequality less than or equal to, I'll have a closed end point here and a closed end point here. Now notice I have 3 intervals on the number line. So this interval will be negative infinity to negative 3. Bracket that off because the 3 is included in the interval. I've got negative 3 to 5, and then I've got 5 to infinity. Okay, so once you've identified the intervals on the number line, you want to use a test value in each interval. So if I test x equals negative 4 from this interval, just pick any real number and keep it simple. That'll give me a negative 4 to the second power minus 2 times negative 4 minus 15 less than or equal to 0. Let's do some arithmetic here. That's going to be 16 minus 7, which will make us have a 9 less than or equal to 0, which is false. So that means this interval does not work. All right. If I choose another value or a different value pertaining, let me get my thoughts right. If I move to the next interval, a solution there or a value there, not a solution, 0 is convenient. So I'm going to test x equals 0. That's going to be minus 2 times 0 minus 15. These terms combine to 0, and of course that's true. So that means this entire interval is a valid solution for the inequality. And finally, I think I want to test x equals 6. It's in the interval, in that third interval. So I've got 6 squared minus 2 times 6 minus 15 less than or equal to 0. So I have 24 minus 15 should give me a 9, which 9 is not less than or equal to 0, so no value in that third interval will work. This is the only interval that works, so then our solution will be from negative 3 to 5, closed in with brackets, and again because of the equal sign here. So we've solved our first quadratic inequality. Let's move to the next one. All right, my equation is in standard form. Let's see if it factors. It's a strict inequality. It's greater than, but what I need to do is change that to an equation. Remember, we have to find the solution endpoints. for our intervals. I'm going to try 4 and 1 because 4 times 3 will get me 12, minus the 1 will get me 11, so I need a negative 12 and a plus 1 there. So solving each of those, I've got a negative 1/3 and I've got a 4. Now because I have a strict inequality, these values will be boundaries in my intervals but not included. So my first interval on the left will be negative infinity to negative 1/3, close parenthesis. I'll have a negative 1/3 to a 4, close parenthesis, and I'll have a 4 to infinity, close parenthesis. So now I'm going to do my test interval. So let's pick a value, maybe x equals negative 1. So let's test x equals negative 1. So I have 3 times negative 1 squared minus 11 times negative 1 minus 4 is greater than 0. So this negative 1 squared will get me a 1 times 3 is 3 plus 11 minus 4. Well, that's 14 minus 4, which is 10, greater than 0. That interval works. So let's get us a value in this interval. Again, 0 pops up, and I like that number because of the ease of the arithmetic. This one you could probably look at easily and see that this term zeroes out and this term zeroes out, leaving a negative 4, which in this case this is false, so this interval is not used. And then let's test a value here. How about x equals 6? And it's just a random value in that right interval. So for x equals 6, I'm going to have 3 times 6 squared minus 11 times 6 minus 4. So that's 3 times 36 minus 66 minus 4. Wow, that's going to be 18. That's going to be 108. Minus 66 minus 4 is going to be minus 70. And then when we subtract that, that should give me a 38. Yep. And that is greater than 0. It is true. So this interval works. So notice we have two intervals. This one, the first one on the left, and the one on the right. Well, when we have two intervals that are solutions, and these are disjoint, the way we write that solution is from negative infinity to negative 1/3, and we always put a union. A comma is not sufficient. We must put the union symbol. And there is our solution to that quadratic inequality. I have one more example to do. If an object is launched from ground level with an initial velocity of 144 feet per second, its height s in t seconds after launching is represented by s equals negative 16t squared plus 144t. So they're just explaining the scenario. We're launching from the ground. Let's get a little picture here. Here's the ground. And we're going to do a launch. We're going to go straight up, and what goes up must come down. I'm going to put a bend in it so that we can at least see the downward motion. This is the upward, that's the downward. This is the initial velocity, which is the rate, and that value is the coefficient of t. Okay? So that is the scenario. Now, when will the object be greater than 128 feet above the ground? So I've got s equals negative 16t squared plus 144t. So I'm looking at this distance, and the formula has to be greater than, okay, in other words, I think it's more clear to write it this way because it follows with the words. This is the height of the object. When will it be greater than 128. I like this version better. It makes a little more sense. Okay? So what we have here is an inequality. So let's get this in our standard form. Now I don't have this one pre-worked. So what I'm going to look for, I'm going to see if 16 is a GCF for, and it is. Okay, and I'm not a real fan of multiplying by negatives, so let's multiply both sides of this equation by -1, and I don't know what is happening. It's almost like my slide gets on steroids. So I'm going to multiply both sides by -1. Now when I do that, -1 times -16 is 16t squared minus 144t plus 128. Now when I multiply by the negative, remember it flips that symbol, okay? Alright, and I'm also going to move my little icon over here. I'm thinking there's a drag effect that is causing that to happen. Okay, the next thing I want to do now is let's work on this GCF. And 16 divides 144 9 times, and it divides 128 8 times. And I think for ease in the problem, let's divide both sides by 16. These factors divide to 1, so I have t squared minus 9t plus 8 is less than 0. Okay? So that thing factors, easy enough. We want to set it equal to 0. Remember, like we did in the previous problems, change it to an equation. I need the factors of 8 that will combine to 9. Okay, so that's t minus 8 equals 0, or t minus 1 equals 0. So let's put this on our number line. I've got a 1 and an 8. Okay, now we want strict. Alright, so what we're looking at, since we have an inequality, we're looking to see what intervals work. So if I have the interval -infinity to 1, I've got 1 to 8. Remember, it says greater than 128 feet. So at 1 and 8 seconds, it'll be at 128 feet. So over here, we could test 0 over here, putting that back in my original equation, or my original inequality, okay, right here. Now, this is what I should use. I'm going to go back down to this simplified form. I'm going to trust that I've done all the arithmetic correctly. That's the danger in using the simplified version. If you've made a mistake, your interval is going to be incorrect as well. Minus 9 times 0 plus 8 is less than 0. So is 8 less than 0? Of course it's not. So then this interval doesn't work. So let's look at between 1 and 8. I've got a nice number here. Let's check 2. So I've got 2 squared minus 9 times 2 plus 8 less than 0. 4 minus 18 plus 8, that's going to be 12 minus 18, which is -6 less than 0. That's true. Okay, so that interval works. And then if I test x equals 9, and again I'm using the simplified equation. Probably if I was working for NASA, I would probably use the original. this 0, so that's false. So this interval does not work. So this is the correct interval to our problem. So when will the object be greater than 128 feet from the ground? When will that happen? It will happen between 1 second and 8 seconds. Okay, right here. So if you'll notice, we shoot the ground, and after 1 second, we're here. Okay, so this is that 128 feet. So from here, it's higher than 128. Here is that 8-second mark. Okay, so there. So between those two times, our projectile is 128 feet above the ground. All right, things to remember. This is a less than and this is a greater than are strict inequalities. All right, the solutions to the equation are not included into the solution set. I should really correct that and say the solutions of the inequality, okay, are not included in the solution set. Those values, oh wait, no, that is right. If I would just read again, get that off there. Okay, the solutions to the equation that we solved, remember we converted, sorry, had a moment, are not included in the solution set. Those were those open circles that we found, remember, like this. Here's a number and here's a number. Okay, we use parentheses for those. These inequalities are non-strict. The solutions to the equation, remember we convert, are included in the solution set. And what we use are brackets for those, like that. And then parentheses are always used for negative and positive infinity. So happy solving quadratic inequalities.